Okay, Bodhi students, we are trying a new platform today. This is called Explain Everything. The other one was kind of glitchy, so we're going to see how this works. We're going to start by talking about our basic angles. So the first one is a right angle. A right angle looks like this, and it is at 90 degrees. An acute angle has to be less than 90 degrees. An obtuse angle is greater than 90 degrees. And a straight angle is exactly what you think it is. It's a straight line, and it equals 180 degrees exactly. So we're going to classify each one of these as right, acute, obtuse, or straight. So we're going to look at angle F or AFB. So AFB. It says that's 20 degrees. So a 20-degree angle would be acute. Okay, the next one is EBF. So start here, I think that's going to have to be EFB. I think that's a typo. So let's change that to EFB because it's not going to work if we don't, because the vertex has to be in the middle. So that is definitely greater than 90 degrees because here's a 90 degree right there. So that has to be obtuse. Okay, the next one is AFE. So that's going to be a straight angle. And then we have BFC. And that's marked with that little mark, which indicates a right angle. Okay, now it's going to ask for name angle DFB in another way. So when you're naming angles, all that you have to remember is the vertex. The vertex has to be in the center. So let's find DFB over here. So here is DFB. So the vertex has to stay in the middle. By the way, that's your angle symbol. Some people kind of make it look like a less than sign, but it really should be angled down and straight across. It should be BFD. Okay, then name a pair of congruent angles. So congruent angles are angles that have the same measure. Well, it looks like this one has 35 and this one has 35. So angle EFD is congruent to angle to angle DFC. Okay, the next one says name a pair of adjacent angles. Remember from your vocabulary that adjacent means that they are touching each other. So we have a couple of options to choose from. We could name the same two angles again because they are adjacent, but I don't want to do that. So I'm going to name angle BFC and angle CFD. Those angles are adjacent. They are touching each other. And then name the angle bisector. So you're wanting the ray that cuts an angle into two equal pieces. So if this side's 35 and this side's 35, then you are talking about the angle or the ray that cuts that angle into 235 pieces. So that's going to be ray, now remember you start with the endpoint, FD with the ray symbol above it. Okay, so now let's look at angle bisectors. It says, so we're on the next example down here. KJ and KL are opposite rays. Opposite rays do create a straight line. KN bisects LKM. So that creates this angle congruent to that angle. The measure of LKM, so the big angle, the measure of this big angle is 7x minus 5. And NKM, so this small angle right here, is 3x plus 9. Find the measure of LKM. So you want the whole thing. Well, if this is 3x plus 9, this side also has to be 3x plus 9. So you can either add those two together, or you can say there are two of them. So 2 times 3x plus 9 equals the entire angle, which is 7x minus 5. So if we distribute, we get 6x plus 18 equals 7x minus 5. So when we solve, 23 equals x. That's not the answer. It wants the measure of LKM. So that's 7 times 23 minus 5. And I don't have my calculator with me, but you guys can go ahead and pause the video and calculate that and find the answer. Okay, so now we're going to talk about complementary angles. Complementary angles in your vocabulary lesson, complementary angles meant 90 degrees together. They do not have to be adjacent to each other. They don't have to be touching, but just together their measures are 90 degrees. So if two angles are complementary, the measure of one angle, so I'm going to call this one x, is 20. Or is 21, sorry. The measure of one angle is 21 more than twice the measure of the other angle. I'm going to call the other angle y. So it's 21 more than twice the other angle. Find the measure of both angles. Find the measure of the angles. So if this is one and this is the other, so here's the other one, we know that x plus y equals 90 degrees. We also know that x equals, click the wrong button. We also know that x equals 2x or 2y plus 21. Plus y equals 90. So combining like terms, we get 3y plus 21 equals 90. So we get 3y equals 69. Divide both sides by 3. Y is 23, so there's one angle, 23 degrees. X is 2 times 23 plus 21. Now we know it should equal 90 degrees, so we really could take 90 minus 23, but let's check and make sure that that works. So that's going to be 46 plus 21, so 67 degrees for the other angle. Okay, so supplementary is 80 degrees together. Now remember, supplementary also doesn't mean they have to be adjacent. It just means that when you add their angle measures together, they equal 180 degrees. So if the supplement of an angle has a measure of 78 less than, here's an angle, let's call it x. It's 78 less than the measure of the other angle, that should say other angle. We're going to call that y. So x has a measure that's 78 less than the measure of the other angle. So here's the other angle. So we know that together these equal 180 degrees. So y minus 78 plus y equals 180. 2y minus 78 equals 180. So we're adding 78 to both sides. Challenge my math skills here. That's 258. You guys probably should check that. Make sure I did it right. Divide both sides by 2, so that's 129 for the first, or for the second one. And the first one would be y minus 78. So 129 minus 78. So that's not 1. How about 51? I think that's 51. Check that for me. I'll put a smiley face there. You're going to want to check the math on that one. Okay, in the next example, we want to find the measure of FGE. So let's find FGE first. So here's FGE. And we want to find the value of x so that FC, so here's FC, is perpendicular to AE. So we're really just wanting to prove that's 90 degrees. That's all those fancy words are meaning. So if FGE is 5x plus 10, and we want that to equal 90 degrees, so we'll subtract 10 from both sides. So 5x equals 80. We'll divide by 5. 16. Okay, so we're going to skip this proof for now just for the sake of time. We may come back a little bit later to it. Okay, so on this one we want to solve for the values of x. These are supplementary or a linear pair, whichever you want to call them. Either way, together they equal 180 degrees because they are a linear pair or supplementary. So that means that x squared plus 70 plus 3x plus 100 equals 180. Now this is an x squared right here, which means we're going to have to factor to find some answers. So we combine like terms, we have x squared plus 3x plus 170 equals 180. To get it equal to 0, we'll subtract 180 from both sides. So x squared plus 3x minus 10 equals 0. So let's see if this factors. Okay, remember you want factors that multiply together to get 10, but add together to get 3. So if you take 2 times 5, you get a positive 10. So one of them needs to be negative. And if you have a negative 2 plus 5, you get a positive 3 when you add them. Set those both equal to 0. So x is 2 and x is negative 5. But we have to check those both to make sure that they work. So let's take the 2 and substitute it in first. So we have 2 squared plus 70 So that's 4 plus 70, which is 74. That seems like a valid answer. And 3 times 2 plus 100, that's 6 plus 100, which is 106. Together, those make 180, so that one checks. Let's try negative 5. Don't forget to put it in parentheses. Negative 5 squared plus 70, so that's 25 plus 70, so 95. 3 times a negative 5 plus 100, so that's negative 15 plus 100, so that's 85. 85 plus 95 is 180. So both of these answers are valid answers. Alright, so the constructions, I will post a video for that, or when you Skype in, maybe you can catch part of the constructions when you Skype in today. Homework is on your calendar, which you'll hear again if you guys manage to Skype in, and we'll see how this new arrangement works.